right, hello. I hope everybody has watched Chapter 6, Part 1 lecture. I'm now going to be working example problem 6.1 on page 282 in the book. So, example problem 6.1, page 282. Example 6.1, page 282. Can you all see that? Yes. All right, for this problem, we're going to be looking at power production of heat engine. So we just talked about heat engines, and we're going to be talking about power production. So for this problem, heat is transferred to a heat engine from a furnace at a rate of 80 milliwatts. Nope, megawatts, 80 megawatts. I always do that, 80 megawatts. If the rate of waste heat, rejection to a nearby river is 50 megawatts. Did I write that time? Determine the net power output and thermal efficiency of the engine. All right, so we have some sort of system like in this figure here, where we have a furnace supplying 80 megawatts of heat per time, megawatts, into a heat engine, which is in the cyclical process where we have a boiler, a furnace, a condenser, and a pump cycling around. And this condenser is discharging to a river here as its low temperature sink. So we have 80 megawatts of heat coming in, 50 megawatts of heat coming out. And we are doing a certain amount of work with this turbine shaft here, and we want to determine this work per time and the thermal efficiency of this engine overall. All right. For part A, we're looking at net power, this power here. And the way we want to do this is by using the equation that was presented in the first part of the lecture. Sorry. So the first part of the chapter here, we can see on page 279, we can use our work net out being our work out minus our work in. And we know work out minus work in, work net out. This was presented in the first part of the chapter in the earlier lecture. We can also set work net out in terms of heat energy. So our heat energy coming in minus our heat energy coming out. These are the same for a closed system undergoing a cycle. All right, so coming back to the problem. We know that our work per time net coming out, which is going to be this power produced by the heat engine, is equal to our work out minus our work in, and it's also equal to our heat transfer out minus our heat transfer per time coming in. And these, as I mentioned, these two equations are on page 279 with kind of more descriptions about them if you're struggling with understanding these. All right, so we have our Q at our higher temperature, Q higher temp. This is equal to Q dot H, and this is 80 megawatts. This is our heat transferred from the furnace to the heat engine. Then we have our heat at our lower temp, which is equal to Q sub L, which is 50 megawatts. So what waste energy is being released to our low temperature sink? Plugging this in, work per time net out is Q sub H minus Q sub L, which is 80 minus 50 megawatts, which is 30 megawatts of work. Pretty straightforward if you understand this equation. For letter B, we're going to be looking for the thermal efficiency, which we discussed in this first part of the chapter as being desired output over required input, or net work out over total heat in. So this is net work out, net work out over total heat in. And this is equal to our net work out is what we just solved for, so 30 megawatts. And our total heat coming in is going to be our high temperature heat from our furnace, which is going to be equal to 80 megawatts. Sorry, they should have a hat over it. 80 megawatts. So then this gives us about 38% thermal efficiency. 0.375, rounding up, estimating about 38% efficiency. All right, so this is example problem 6.1 in the book. We are going to continue with the rest of the chapter in chapter 6, part 2. If you'd like some additional practice, please work example problem 6.1 in the book. And also in the back of this chapter, there are some conceptual questions that are nice at illustrating why the second law of thermodynamics is important for heat engines, thermal efficiency, refrigerators, and heat pumps. So working problem 6.1c through about 6.26, 27, you should be able to work through these here in the first part of the chapter. With that, everybody have a great day. I have quality control right behind me, checking the quality of everything. I will see you all chapter 6, part 2. Thanks. Bye.